Haomin Photonics has launched its gigahertz repetition rate locked femtosecond frequency comb. The frequency comb adopts a 2U rack-mounted design and integrates an atomic clock, as well as a dual-channel frequency synthesizer. Reference to the internal atomic clock. The synthesizer can generate signals from 100 MHz to 6 GHz, providing high-precision adjustable reference signals for the internal locking electronics. In addition, the 10 MHz signal from the atomic clock is separately routed to an external monitoring port on the front panel, allowing users to connect measurement instruments or synchronize with other systems conveniently. The front panel of the 2U chassis features a clean and straightforward layout, including the power switch, communication interface, repetition rate monitoring port, 10 MHz signal output port, and external reference signal input port. It supports external reference input, enabling flexible switching between internal and external references. Finally, there is the optical output port. Next, let's move on to the control software and performance demonstration. The software is mainly divided into 3 sections. The left side is responsible for issuing control commands and receiving monitoring signals, allowing users to check the communication status. Below it is the one-click locking button, along with 2 status indicators that display the mode locking status of the internal resonator and the locking status of the control electronics respectively. On the right side is the parameter configuration area. For example, users can adjust the pump current setting to change the output optical power. A step size selection function is also provided, making it convenient to increase or decrease the value in predefined increments. Further down are the settings for the dual-channel frequency synthesizer, where users can configure the output reference signal and switch between internal and external references. Real-time optical power monitoring and power stability measurement results are also displayed. After connecting an optical spectrum analyzer, the output spectrum can be observed to be very smooth, with no obvious nonlinear effects. We use frequency counter to demonstrate the frequency stability after locking. The current counter reading is 668,610 Hz, and we set the target locking frequency to 600 MHz. Once the internal configuration is completed, a confirmation message will appear. At this point, simply click the one-click lock button, and the repetition rate quickly stabilizes around 600 MHz. The locking process is extremely fast. After enabling the measurement function, it can be seen that the overall frequency fluctuation is below 2 MHz, typically remaining between 2 MHz and 4 MHz. The fluctuation is exceptionally smooth, demonstrating outstanding locking stability. Such frequency stability enables this frequency comb to support a wide range of dual comb applications, including dual comb spectroscopy and distance measurement. It is also highly suitable for the generation of high-frequency microwave signals. For example, microwave signals at 100 GHz or even to 100 GHz can be generated by combining this femtosecond frequency comb with our broadband UDC PD and electrical filters.